Hello everyone. In this video I'm going to work through this ridiculously long Dijkstra's algorithm question. You can see here we've got a huge network. We have an alphabet's worth of nodes of vertices, and it really is a cruel question. But I suppose in doing this question we can really build up our sort of self-check strategies, and frankly if we can do this question we can do any question. So I really wouldn't recommend you listening to the whole video. What I suggest you do is, have a go at the question yourself, and then perhaps just use the video to check your answer. So I'm going to make a start. So we're starting at vertex A, and we're trying to find the shortest path to vertex Z. So we've got the trivial thing at the beginning here that we're starting at A, and because we're at A, we can get there in 0. So that's going to be the first one that we connect. Now from A, we can connect to vertex B, that's currently unconnected. We can connect to C, D, E, or F. They're all the unconnected vertices that we can connect to. So we can get to B in 12, C in 6, so these are called temporary labels, D in 16, E in 3, F in 16. So we look at our temporary labels now and we pick the lowest. The lowest of course is E. So that gets a permanent label, it goes here. That's the distance, and that was the second vertex to be added into our solution, so that gets the 2 there. Now that that's in, you really focus in on this vertex and you think, now that that's in my solution, what other vertices could I connect to? And of course we can go to H and we can go to M. So that's where our focus now goes. And we can get to M in 8, add 3. So we can get there in 11. And we can get to H in 16, add 3, so 19. Now you've got to take a step back and look at the whole network. You need to look at the vertices that are not yet connected. So we've got B, C, D, F, H, and M, and we pick the lowest number. And the lowest number is, of course, the C. So that is now going to permanently go into our solution. So that gets the permanent distance of 6, and it was the third vertex to be added. Again, now that that's in our network, in our solution, we consider all the new unconnected vertices that we can get to, and we can get to K in 6 add 59. So 65. Take a step back. 12, no, 12 isn't the lowest. If you look around, we need to have a good look around, we can see the M is the lowest. So that's going to be the 4th one to be added. Right, now let's focus in on M. Let's see where we can connect to. Now, K is currently unconnected, and don't think that you can sort of not go backwards. That's absolutely fine. So we can go to there for the second time. We can't go backwards to here, of course, because E is already connected. We're just going to consider the unconnected ones. So we can go to H, and we can go to R. If you just look around, there's 4. It's got degree 4, vertex M. But this one we don't count, so we just consider these 3. You've really got to make sure you consider all of the possible routes leaving M. So if we go to K, we can get there in 11 add 15, which is a big improvement. So we cross that out and we put 26 here. We can get to R for the first time in 11 and 9, so 20. And we can get to H for the second time in 11 add 7, which is a slight improvement. So that's now 18. We take a step back now. So it's getting messy. We need to have a good look around. B12 is probably the winner, but let's see if anything beats that. And no, so B is now going to be added. This is the fifth vertex in our solution. Size 12, that's distance 12 there, sorry. And now we consider where we can now get to, there and there. We can get to J in 90, there we go. We can get to I in 62. Let's take a step back, look at what we've got. K is 26, but our H, I think, is going to be the winner. No, F. You really got F and D, 16. We've got to have a good look around, look at each unconnected vertex. So one of those 16s is going to go next. It really doesn't matter which one you pick, you choose yourself. I'm going to pick D, just going in alphabetical order, really. So the D gets the permanent 16. I'm forgetting which number this is. What was that number up there? The fifth one. So this will be the sixth one. We can now connect to here, but it's not a very good route because 57 and 16 is way higher than 26. So that's not very good. So D's not really produced an efficient path, really. So F must be the next one because that was also 16. So that's the seventh one, 16, and we can get to there for the first time. We get there in 37. Take our step back now. Look at all the unconnected vertices. We've got all that first lot, that B to F, connected now, so we don't have to look at them anymore. H being 18 looks like it's going to be the lowest, but check every single one. Indeed, it is the lowest. So H is going to be the eighth one. Now let's consider where we can get to. We can go backwards to G, that's still unconnected, but we can't go this way or that way because that's going to connected vertices. And actually it's pointless going back to G because that would take 40, so that's not an improvement. So let's look at another unconnected one. Right, so K is 26, but we can beat that. We've got R as 20 out there, so that's going to be the next one. That will be the ninth one to be added. So let's add in R now. And consider all of the vertices that we can now connect to. There's rather a lot. We can go up there for the first time. We don't go backwards to M because that's connected. We can go to there, there, and there. So consider all of these in turn. We can get to Q in 20, add 23, so 43. We can get to U in 30 and 20, so 50. We can get to X in 89 and 20, so 109. We can get to the T in 7 and 20, so 27. Okay, so we've done our job there. Now we literally take a step back and look at all of the unconnected vertices and we pick the lowest number. T being the 27 is possibly the lowest, but no, it's not K. You've got to check everyone. K being 26 is the next lowest. That's not beaten by anything. So we'll go to K next. That's going to be the 10th. Let's think about the implications. We can go to Q. Oh, you can see we're not going to get there in less than 43 because it would be 26 at 43, so that's not useful. and then K doesn't connect to any other unconnected vertices. All the other ones are connected vertices. So let's take our step back. Let's look at the next lowest, G37 at the bottom there. But T is 27, despite being quite far to the right. That's the lowest one. So that's going to be the 11th to be added, T. And let's just consider there's only really one edge that it could possibly go to somewhere unconnected, so it goes to V at the top there. There we go, right up there in 27 add the 30, so it gets there in 57. So it's taken a very long time, but at least we've got to V, and so we're almost there, perhaps. So perhaps we won't necessarily fill in all of these labels. You can get to Z without filling in all the letters, and I'm kind of hoping that's going to happen. Right, having a good look around then. We've got I at 62 up there, but Q at 43, so that's winning so far. We've got G down here at 37. So that's the next one, and that's going to be the 12th. Now let's consider, we've got the 21 and 22 going backwards there into connected vertices, but let's consider these. All of these come into play for the first time. All of these are currently unconnected. We can get to O in 37 add 12, N in 6 and 37, we can get to the L there in 25 at 37. That's 37, 42, 62. And let's go to the big view. N is 43, that's quite low. Scanning around. I've got two 43s. Are they the two lowest? I believe they are. I can't see any others that are going to beat the 43s. I'll go with this N here at the bottom. That's going to be the 13th to be added. So we can get to S for the first time over a different route, and that's it really in terms of unconnected vertices. So O, we can improve that, 43 add 3, so 46. And S we can get there in 2 45s minus 2. Big view now. Of course we had the other 43, so presumably we go there next. So that's going to be the 14th Q. Let's think of the implications. We can go here for the first time. Just checking, yeah, that goes back to K, so that's fine. So there for the first time, and there for the second time, and that doesn't count because ours connected down there. So we can get to P in 43 add 15. So 53, 58. We can get to V in 43 at 29, so that's not going to be an improvement at all. So big view again. So I's at 62, we've got V at 57, that could be the winner. No, it's not, because U is at 50. No, that's not even the winner. We've got O at 46. A good scan around. Make sure you've looked at every unconnected vertex. This is where we can go wrong by just missing something. So O is going to be the next one. That's going to be the 15th to be added. Let's think of the implications. We can go to P for the second time, but that's 9 add 46, which gives us 55, which is an improvement, so that's nice. Where else can we go? I don't think we can go backwards to here because this is connected down here, but we can go to, let me just not zoom out quite so much, I think. Okay, that's perhaps better. So we can get to Y now for the first time. We can get there in 82 add 46. So we've got 120 there and an 8, 128. And we N is already connected, so P and Y were the only unconnected vertices, so we're doing our job there. Looking around, we've got U at 50, could be the winner. And I don't think that can be beaten, so we're going to go there next. That's going to be the 16th to be added. And the implications are we can go to V here, but it's not an improvement, so that would be 65. But we've got a considerable improvement here. We can get to X in 68. And they're the only considerations. So big view again. I am blocking the X there with that annoying tool that keeps popping up. So looking around, we do have X at 68, which is so close to the end. So we've got L here at 62. And we've got I at 62, but we've got V at 57. So that should be the next winner. Have a good scan around. And then we've got P at 55. So that's the next one, and that's going to be the 17th P. Implications are none. They only connect to Q, which is connected, so that really didn't matter much. Let's go back to the view again. V at 57. That's the winner. That's going to be the 17th. Let's think about the implications. We can get to W. We can get there in 62. And we can, I was going to say we can go backwards to J, and we could do, but that's going to be 107, so that's not going to be an improvement. Big view again. We have the 62 that's still not been picked up with I, and 62 at the bottom with L. They're the two in the sort of first half of the network that still haven't come into the solution. So they could be the winners. Let's just get rid of this. In fact, we've got a lot of 62s to choose from. And they are the lowest. I'm just going to have a quick check. I feel that I could go wrong here. So, yes, it's just lots of 62s. I think I'm going to try and fill these in at the front, and maybe they'll just be taken out of the solution. I62, so that's going to be the 17th, is that? Yes, that's the 17th. So V is 17th, so it's going to be the 18th. So this is the 18th, that's 62. we can now get to J via a different route that's slightly more efficient, is 68/78. Now we're just going to fill in the other 16s. We can go to L here, and that's going to be the 19th, and that means that we can now get to S in 90. Well, it's not an improvement, so that's that one done. And the other 62 is up here, and so that's going to be the next one to go in, and that's number 20. And that means we can actually get to the final one for the first time. We can get there in 85. I apologize, 75. Okay, so I feel I need a break now, but I shall persevere till the end. Looking around, so they're the 62s out of play. Early in the network, we've still got the J at 78. And then sort of in the middle, we've got the S at 88. We are nearly there now, which is excellent. We've got the X though at 68. So that's going to be the next one. And that's the 21st to be added. And that gets the permanent label of 68. And the implication there is just that we can now get to the end, but it's going to be a lot bigger than 75, 45 at 68. So that's that one done. So the next one, again, we've got the J at 78. The S isn't better than that. In fact, we can get to the end in 75. That is the lowest. So, well, that's the 21st, and that's 75. So I can't say I'm completely confident that I got this one right, and you know, this is going to be posted on YouTube, and perhaps you're all going to be commenting where my error actually is. But because we've actually filled in the Z one now, we can stop the algorithm. We don't need to keep going and filling in the rest. Whenever you permanently fill in any vertex label, it's telling you the shortest way to get to that vertex. So if you say, look at M, that's the fourth one to be added, the shortest way, the shortest distance you can get to M from A is indeed 11. As soon as it permanently gets filled in, then you know that is the truth. So we can get to Z in 75. So I'm going to fill that in at the bottom. But now what I'm going to do is backtrace through the network, and we can work out what our actual path was. Now clearly, when we start here, we can't have gone through the Y because that's not even been filled in. 75 minus the 45 does not equal 68, so we must have gone this way, which in turn means we must have gone that way. Now 57 minus 15 doesn't equal the 50. 57 minus 30 though does equal the 27, so we must have gone that way. Then 27 minus 7 equals 20, so we must have gone that way. 20 minus 9 equals 11, so we must have gone that way. 11 minus 7 does not equal 18, but 11 minus 8 equals 3, and 3 minus 3 equals 0. So that is the shortest path there, which we just label it as A, E, M, R, T, V, W, and Z. Right, well, you've done very well if you listened to all of that. I think I'm going to go have a nice cup of tea now.